Alright, so I'm going to show you some information with the PicoScope 5000 series and using them as a differential mode, and where it can be really handy having these multiple bits. So what I have set up here is two waveforms imposed on each other. So there's a 5 megahertz wave. This is what I'm actually interested in, and it's being sent differentially over a channel that has a 2 megahertz wave, a huge 2 megahertz wave on top of it. So you can see if I decrease the 5 megahertz, what I want is gone away. When I click on the signal generator, I'm generating this 2 megahertz wave. So I've just done this with a transformer coupling, and I'm now using the math channel on the PicoScope at the bottom part here to generate this, the differential waveform. So ideally what you would do is, you could have it at this plus minus 50 millivolt range, and you'd get a really nice signal at the bottom part here. And you can see how those are exactly differential, the two sine waves. But the problem is that I need to use a plus minus 1 volt range because of how big this this 2 megahertz carrier is. And what you can see is that when you have the 8-bit resolution on that 2 megahertz range, the 8-bit resolution, it's really killing what you're seeing in the differential channel. Whereas when you can switch to the 15-bit using the dynamic resolution, it makes your life a lot easier because you're seeing a much more accurate representation of that differential waveform. And as an example, we can switch on, afterwards I'll switch on channel C, where I have a differential probe set up on that channel. So that's obviously an even better way to do it. But you have to have that special probe on hand. It has to work in the specific range you're looking for. So let me just save what I'm seeing using just the math channel on the PicoScope, and then let me connect the differential probe. It'll screw up the A and B measurements, so that's why I save it first. Okay, there we go. So there's the output of the differential probe also viewing this. So you can compare the output of the differential probe to the A minus B math channel, and you see that they're actually quite similar. And that's with an 8-bit resolution on the differential probe, which is what your typical oscilloscope has. So if you have the differential probe, you could of course go to even higher resolutions using this dynamic system. But if you don't have it, you can just use the two input channels as 15 bits.